So what's up everyone, welcome to Nodes and welcome to our next video on our JavaScript story side of things. And today we will discuss our further concepts in our JavaScript fundamentals, right? So here you can see that I've opened my roadmap side of things, and here I have added some new topics and I have also changed their colors as well. Okay, so today we will be discussing about call stack and heap memory, and I think these are only the two components which are the part of JavaScript engine which we have not discussed yet, right? So we'll be discussing about call stack and heap memory, and moving on we will discuss about the concept of garbage collection, and we will also discuss about some of the JavaScript code patterns in which you can create memory leaks and stack overflows in your code. Okay, so with that said, let's get started. Okay, so let's bring in our JavaScript engine side of things. Okay, so let me just bring our JavaScript engine side of things. Let me just zoom in for now. Okay, so this was the engine which we have already discussed, right? And here you can see that I've added those two components which we have missed, right? So number one is the call stack and the second one is the heap. Okay, and we will discuss what these components are and how they help JavaScript in code execution, right? So for understanding call stack, let me just first give you an example of how call stack works, and then we will move on to the underhood concept of call stack, how this concept emerged in computer science, right? So let's come on to our VS Code side of things, and here you can see that I've already created a function add, which is adding just two numbers, and then I'm having another function which is with add number, and then I'm calling the same function above right over here. Okay, and at the main side of things, or at the global level, I'm just calling this add function, add number function, right? So let me just save this thing, and at this point I will just call the debugger statement right over here. Okay, what this will do is that this will pause the execution of my JavaScript program at line number 12, and then we can start tracing how JavaScript executes the code. Okay, and here you will see that call stack will help JavaScript to know that where he has started the execution and where he will end, right? So let's start the procedure. So let me just save this thing, and let's come on to run side of things, and let's start debugging. Okay, so once you start debugging, you can see that on line number 12 the interpreter has stopped, or I would say the execution of JavaScript code is stopped, and we are also having terminal right over here in which we can execute some of the JavaScript side of things. Okay, and on the right side you can see we are having different things. Okay, so we are having our variables listed over here. Okay, so we are seeing that we are having that add function which is already read by JavaScript, okay, engine, and we are also having add number function which is also read by JavaScript engine right now. Okay, and these are some of the things which we will discuss further on in the video series, right? But right now we are discussing about call stack, right? So let me just resume this, and here you can see that we're also having option of call stack right over here. Okay, and right now you can see there is something on the call stack which is known as anonymous. Okay, and we normally call this as the global execution context. Okay, again the word sounds very much confusing. Don't worry, we'll cover that in the coming on videos, that what the global execution context is. But right now just assume that whenever JavaScript program starts, the very first thing that is pushed onto the call stack is your global execution context, and it is shown as anonymous in your call stack right over here. Okay, so let's say right now our execution is, let me just hide the terminal for now, and you can see that here the execution is stopped on line number 12, right? So if I click on this, it will go to line number 13. I mean, it will go to the next step, right? So if I click on this thing, you can see that right now we are at line number 13, add number. Now this add number function will be called, right? So as soon as I go to the next step, you can see the function is called, and we are at line number 7 inside this function execution, right? So here you can see global.add number, this function is pushed onto the call stack, right? So once that is pushed onto the call stack, you can see we are inside that function, and we are now we will just call this add function, right? So what will happen if I go to the next step is that once I click on this, you can see now the execution is on our add function, and this add function is also pushed onto the call stack side of things, right? So here you can see this call stack has our latest add function, right? And this will obviously give us 10 back. So once you click on that next step, you can see this global dot add is working fine. So let's click one more time, and now you can see that add function has been popped off with the value of 10. Okay, so since we know that this function will return 10 and the value is popped off, so the add function has been removed from the call stack, right? So if I click one more time, you can see that now the add number function is also popped off and we will get 10 as a result, right? And if you click on next step, so the next step is that the global execution context will also be popped off from the stack and your program will finish. Okay, so if I click on this thing, you can see that now our program has finished and the global execution context has also been popped off from the stack. Okay, by popping mean that removing from the stack, right? So you can see that call stack helps JavaScript to know that where he has started the code execution and where he has to go next, right? So just assume the concept of call stack as a person who is finding treasure. He is following that path and he is leaving traces behind to to understand or to find out how to come back out of that situation, right? So call stack is just a simple concept like that. Okay, so once something is pushed onto the call stack, JavaScript do remembers that yeah, I am now inside that function. So once I have to go back, I need to remove that thing from the stack, and then I can know that where I started from here, where I came. Okay, so that's the concept of call stack, right? So if you come over here, if you want to really understand the concept of stack, so just remember that a stack is a type of a data structure. We call it LIFO. LIFO means last in, first out. So whoever comes last will be given the first priority to get out, right? So this is something like this. If you really want to remember the concept of stack, so I would just say, just remember the concept of stack of books, right? So this is the concept of stack of books. So let's say if I want to remove this last book right over here, so I have to remove all those to get to the last one, right? But if I have to remove the top one, so I can easily remove that because it's already on the top, right? So this is what JavaScript call stack was doing. Remember, so if you call a function, it will be pushed on the call stack. If that function calls another function, it is also pushed and it is also pushed. Okay, and let's say once that function is completed, then JavaScript can easily refer to stack and he will know that yeah, this is the point where I was started, right? So it is just a way to tell to JavaScript to come back out of those functions to the point where JavaScript engine started executing your code. Okay, so that's the concept of stack, right? Now there is also one question over here, which is our Stack Overflow. Remember how we can misuse the stack? So that's the I would give you a simple scenario for that. Okay, so for understanding the concept of Stack Overflow, what you have to do is you have to create a function which will call itself multiple times. Okay, and when we usually call that recursion in the concept of computer science, right? So if I call a function, let's say it's test, and I come inside this and I call the function again. So what this will do is it will keep on pushing the test function onto the call stack, and ultimately the call stack memory will go out of bound, right? And once it go out of bound, it will start complaining you. Okay, so if you just come to our terminal side of things, and if you just clear it, and if you run with node main.js, and okay, sorry, I have not called the function, so let me just call that over here. Okay, so yeah, right now let me just run this, and now you can see it's saying that maximum call stack size exceeded. Okay, so once JavaScript knows that yeah, you are exceeding the limit of call stack size, so it will just complain you that you are doing something wrong with that. Okay, so remember the movie Inception, in which they go inside dream, and inside that dream they go into another level deep, into the third dream, into the fourth dream, and then they start coming out of that dreams and all that. So I think Inception movie is one of the best movie to understand the concept of recursions, call stacks, and all those concepts, right? So this is just the same concept over here. Okay, so right now we are just inside an infinite inception. I would say dream inside dream inside dream. Okay, so it's just function calling inside function, and these functions are just getting pushed onto the call stack, and ultimately since we know that we all have a limited memory size in our machine, so ultimately you will exceed that call stack size, right? So this is the concept of call stack. I hope you understood the concept of call stack as well, and how we can misuse the call stack, and how we can make the stack overflow, right? So that's the concept over here. Okay, so now I think we have discussed those two topics, I guess. So let's bring our famous diagram, our roadmap right now. Okay, And yeah, we have done with the call stack part of things, and we have also done with the stack overflow side of things. Okay, so now let's move on to the heap memory side of things. Okay, so if I come over here, not here, let's bring on our diagram. Okay, so let's go to our this side of things, and let's create a code execution. Okay, so let's say I'm having a code block, and inside this code block I will paste the code which we have written for understanding the call stack side of things. So let me just copy this, and let's bring the code block again, and let's paste it over here. Okay, so let's say this is our code block, right? Okay, so once we know that how this code block will work is, we will be having something like this, a call stack, and the very first thing which will be pushed is will be something the very first function which will be pushed is, is add number side of things. Okay, and this add number will go on, and this will further push something, maybe the add function. Okay, and this add function will then just execute it, and then the add function will be popped off, and then the add number function will be popped off, and finally the global execution context. Let me just write that down as well. So that is our global execution context, right? So these are the three things which are available in our call stack side of things. Okay, so now let's understand the concept of heap. Okay, so heap is something, heap is a place where JavaScript allocates memory for objects, right? So let me just bring in our heap memory. Let's change the color to maybe something different. Okay, so let's call this. Okay, and this is our heap memory, right? So whenever you create variables or objects, I would say since we know that there are two types of data types in JavaScript, there are primitive and non-primitive, right? So I would say the non-primitive types like arrays or objects or functions, those are those are kept inside heap, right? So let's say if over here I'm creating an object, let's say it's const object equals to, let's say, name, and let's say name is notes, right? So let's say this is the object which was created inside this add number function. Okay, so as soon as this add number function will be pushed onto the stack, so this will create a reference to this object which will be referring a location inside this heap memory, right? So let's say if we are having this object right over here. Okay, and this is having a name of, let's say, nodes. Okay, now this function will be referring to this memory location right over here. Okay, so this will just be a reference to that memory block inside the heap, right? So remember that in our call stack, whenever we push something onto the call stack and we create objects on those situations, so those objects are referenced by these by these memory blocks right over here. Okay, so this add number will be having a reference to this memory, and that reference name would be object, right? So this is the object because we have given the variable name as object, right? So heap, in simple words, I would say, is a place in which JavaScript keeps all those all those memory objects, all those objects inside over here, and the call stack functions will be just having a reference to that that memory heap, right? So that's the concept over here. Okay, so another thing I want to discuss is, so let's say if there is another, maybe a string. So let's say const test equals to let's say there is a string of, maybe let's say name of afaq, right? So now this string is a primitive data type, right? So there are some situations in which JavaScript doesn't allocate memory inside the heap, but rather it keeps the variable onto the same call stack side of things. Okay, so if I just bring in the rectangle right over here, and let's just send this to backward. Okay, so change order, send to back. So this add number will be having a string of afaq named as test inside the same call stack, right? So we will be having the same variable right over here. So let's say that test variable is also inside this call stack, right? So that will not create a reference of memory heap, right? So there are some situations in which JavaScript keep the, I would say, the data in the same call stack, and there are some situations in which they refer to the memory heap, right? I think most of the time whenever you create work with the primitive data types, so the primitive data types are always kept in the call stack side of things. So, and the non-primitive data types like objects or arrays or all that are always referenced to a memory heap, right? So that's the concept over here. Okay, So I guess this is the concept of heap, and I have clearly explained you that how heap works and what are the concepts revolving here. Okay, so now let's discuss about garbage collection. Okay, so since we all know that JavaScript is garbage collected, so garbage collection simply means that, let's say, if there is a point in which JavaScript knows that, yeah, this object the user who has created is now out of reference. Out of reference mean that there is no other variable pointing to that memory location. So the garbage collector can comes in and can remove that memory location and can free up that memory, right? So if you come over here, I think I was having this site. So this diagram will just give you a glimpse of how garbage collection works, right? So here you can see that since our call stack is pointing to our object and that object is always pointing to multiple other objects, okay, so since we know that these objects are being used, right, object 2, object 1, object 3 and object 4 are being used because somehow they're being referenced from each other, right? So by reference means, so let's say if I'm having, let's say, const object, right, and this is having a name, okay, and this name is afaq or maybe something different, okay, so let's say it's afaq, and again we can create some another object 2, which can again further point to first object, and then we can create object maybe 3, and this object 3 will be pointing to object 2, right? So again you can create multiple references. You can reference one location to another and can go nested level, right? So this is the same situation which is being done right over here, okay? So the one object is pointing to another, okay, but there is situation in which there are objects, or I would say there are memory locations which goes out of reference. Out of references, there is nothing in the call stack which is pointing to that object, right, or that memory location. So the garbage collection will come, he will start tracing, and you will see that, yeah, object 5 is not being referenced, object 8 and object 7 is also not being referenced by the call stack. So the garbage collection will comes into the picture and he will remove all the objects which are not being referenced by the call stack, okay? So let me give you example for that as well. So let's say if I come over here and I just create an object equals to, let's say, name, and this is a fog, right? So this is the object which is pointing to a location in heap with this data right over here, okay? So this will be something like this. Let me just bring back our diagram, okay? So let's say for now there is on the call stack there is nothing for now, so let's just remove this thing for now. Let's remove this as well, and this name is notes right over here, okay? So let me change this to a fog, okay, and let's say this is a fog, okay? And now I know that I have created this variable, right, object, and this object is pointing to this memory location. So I can come over here, I can say this object is referencing this memory location right over here, okay? But now let's say on the next line I come and I say that, okay, for changing, let's call it let, because I want to change the value. So I can say that object equals to maybe a string, okay, or maybe I would say something different, okay, maybe let's say object equals to null, okay? So now things are different because now JavaScript garbage collection is smart enough to know that, yeah, it was first pointing to this location, and now on line number 7 it is saying that, yeah, now it's null, okay? So what is happening is I am removing this reference and I am saying that this object is obviously equal to null, okay, and now that reference has been removed, okay? So what will happen is that the garbage collection will come into the picture and will see that, yeah, this memory location was booked by the developer before, but now it is not referencing to anything from the call stack, right? So I can just come over here and I can delete this thing from the heap. So that's how garbage collection works in JavaScript, right? So that's the concept here, okay? So I think we have covered most of the topics. I think one last topic is left. If you come to the roadmap of our diagram, that is our memory leaks, okay? And memory leaks mean that somehow you exceed your memory heap, right? And that can happen in different situations, right? So let me just come over here and let's say I'm creating an array and this array is empty, right? And I'm come over here and let's say I'm having a while loop, and inside while I'm just running the loop infinitely. I'm saying array dot push, or maybe let's say 1, okay? So what do you think will happen, right? So it will keep on pushing the value 1 until your heap goes out of memory bound, right? Your heap will be finished, or I would say your heap will be completely filled, okay? Because this is pushing the data infinitely, okay? And once it's pushing the data infinitely, under the hood it will just fill up your all the heap, right? So that's the concept of creating memory leaks. And the second one I would say is the set interval. Okay, so if you come over here, the set interval, if let me just take you the official documentation for now. So let's go to set interval JS, and yeah, this is the official documentation by Mozilla. And once you come over here, you can see that in the set interval side of things, it's just a function which will repeatedly call the function or execute a code snippet with a fixed time delay, right? So you can provide the code and you can also provide the delay. Okay, so how can you use it? Let's say set interval, and let me just remove all the above code. Okay, so it's set interval, and here the first parameter is our code. Okay, so and the second parameters are time, right? So this will be our code. Okay, and inside this, maybe I would say maybe I would be doing some of the operations, and I'm doing that operation for every 1 second, right? So what this will do is this will keep on running after every second. Okay, and let's say if I'm using any variable, or maybe I'm pushing the values onto array, or if I'm doing something different, right? Until and unless I don't clear this set interval, it will keep on running and it will keep on using the heap memory storage, right? And what the result will be? The result will be obvious that under the hood the heap memory will be filled completely. Okay, so the good practice is that you can clear this interval by passing that interval reference, I would say, and then that interval will be removed after this execution of line of number 11. Okay, so that's the concept here. Okay, I remember a case study of, I would say, SoundCloud, I guess. So SoundCloud was I guess of a MP3 streaming website in which the users were running the website in the background for long periods, and for long periods the streaming was being done, and under the hood it was using a lot of heap, and at some point the heap was exceeding the limits and the websites was crashing, right? So that was one case study of SoundCloud, I guess, in which they were facing memory leaks. And the second is obviously YouTube, right? So if you guys normally use YouTube and you play songs on the background, so you notice that after some period of maybe 30 minutes or 20 minutes or whatever the interval is, YouTube pops up a dialogue and asking you that are you still watching or not. Okay, the reason they're asking is because once you run anything on the background constantly, at some time your heap memory will exceed, right? So that's the reason the YouTube guys are asking you that, yeah, if you are using, so let us know so that we can do something with the heap, or we store something, or we remove some of the data. So I would say that's the concept behind that. Okay, so yeah, I think, yeah, that's the concept of memory leaks. I guess we have covered most of the things over here. So if you come to our roadmap side of things, we have discussed the call stack, the heap memory, the garbage collection, the memory leaks, and the stack overflow thing. Okay, so I guess we are done with the basic understanding of how under the hood JavaScript engine works, right? So in the next coming on videos, we will discuss the asynchronous nature of JavaScript, how JavaScript executes the asynchronous code, and how we can understand that concept, right? So I think, yeah, that's it for now. I hope you're liking my content. So if you're liking my content, do like and subscribe the channel. I will see you in the next video. Thanks for watching.